Our universe is quite big. The planets, stars, nebulae, and galaxies make us realize how insignificant we are on the cosmic scale. But what if I say that these account to merely 5% of the observable universe, with 95% of it being composed of something we have never seen directly, something we call dark matter and dark energy, about which we know almost nothing. Mind-boggling, right? This is Q&A, and here is the answer to the question, what is dark matter? Everything you see around is composed of something called baryonic matter. Be it the chair you are sitting on or the largest planet in the solar system. But the universe at its large scale has a different story to tell. 27% of it is composed of dark matter and 68% is composed of a completely different form of energy known as the dark energy. But what we see around is just the remaining 5%. Now you might be wondering that if we cannot see this so-called dark matter, how do we know it exists? And the answer is by analyzing its effect on the visible matter. The story dates back to 1933 when the Swiss astronomer named Fritz Zwicky was studying the Coma cluster that contained more than 1,000 galaxies. He found something very strange. The galaxies in this cluster were flying off at a tremendous speed, far more than what theory had predicted. Zwicky said there is invisible mass in the cluster that might be even more than what we are seeing. Many scientists ignored this new discovery and the so-called hypothesis of dark matter, but what came next could not be ignored. I want you to go back to your high school chapter of solar system. Remember we were taught that farther a planet from the sun, more time it takes to go around it. Example, Venus goes around Sun in just 225 days, while Saturn takes 29 years. If that is the case, same should be true for galaxies. That is, stars in the outer edge should be moving slower than the stars near the center of the galaxy. But what astronomers found completely shocked the scientific community. The stars moved at the same speed regardless of the distance from the center. This means the entire mass of the galaxy is not concentrated at the center. There is more matter in the galaxy, and this is what we call the dark matter. Now, if dark matter exists, there must be an elementary particle associated with it. The current model, that is, the standard model of particle physics, has no such particle that can describe the dark matter. It completed in 2012 with the discovery of the Higgs boson, the last missing piece of the standard model. There are three ways in which dark matter can be found. The first is through telescopes, doing cosmology, and this is the only way we know dark matter exists. The second is through detectors. We build super sensitive detectors, and when dark matter particles fall on them, we get the signals. The third is particle detectors. We collide beams of particles and they annihilate into pure energy. Out of that energy, new particles form. Scientists are hopeful of directly detecting the dark matter in the next few years. However, many think dark matter is the new ether, something that doesn't exist. Whether it exists or not, dark matter is certainly one of the most important unsolved problems of science. Share this video with your friends, and in the comment section below, do ask questions for the next episode of Q&A.